Hello everyone. Can I do a sound check? Can anyone hear me? Or can everyone hear me? Oh my, I'm lagging pretty hard. Okay, let's hope my internet keeps up. Hello everyone. Here, let me try something. Is there a better angle for this? I don't think so. Okay. Hello everyone. Alright, sweet. Nice, good sound check. Oh yeah, there is a delay, by the way, between... Hello everyone. Sweet. My computer will be kind of laggy, so I hope you guys can handle that. There is a delay between what I say and when you guys hear it. That's just how streaming works. I'm glad you think this is cool, Harith. Alright, so what are we going to be looking at today? Obviously functions and scope. But before that, if you're checking on this channel and you're not in the Google Classroom yet, go ahead and check the description. I have included I've included the code to use to get into the Google Classroom. So yeah, again, little PA. If you're not connected to the Google Classroom yet, go ahead and join using the code below in the description. And also, if you also school emails won't work, so you can't use your student.musd.org account. All right, yeah. Why don't we just get started? We're only gonna go over one lesson today. Now, if you didn't go to the physical class last Wednesday, or you haven't watched the videos that catch you up yet, go ahead and pause this stream or whatever, and then watch those videos on the channel. Javascript 1 and 2. It's about variables, booleans, conditional statements, that kind of thing. And once you're done with that, you can come back here and then keep on watching this stream. So I hope my internet can support this. I'm like barely scratching 30 FPS, so let's not lose the stream. Hold on. We'll jump right in. Just give me a second. Gotta configure some things. What? Oh my. Yeah, my internet is really slow. Alright, sorry for the dead time. Okay, let's get this started. Okay, JavaScript, functions and scope. So, hello everyone, welcome to the next lesson, functions and scope. Now before I hop into this lesson, or actually before you hop into this lesson, you already have hopefully a strong understanding of... I want to restart. Okay, you guys are going to experience me restarting this over and over again. Okay, hello everyone, welcome to the next JavaScript lesson. Today we are going to be going over functions and scope. Now, by this point, let's hope you already have a strong understanding of variables and Boolean operators and such. So why don't we hop right into it? So let's, before we do anything, let's go ahead and hop into our favorite IDE, playcode.io. And then I'm already logged in, but you should go ahead and log in as well. Alright, okay, now that we're logged in, I'm going to go ahead and scratch all this. Let's go to the slides real quick. Let's check this out, functions and scope. So, what are functions? It's ways we can reuse blocks of code. It's like another shortcut device. Yeah, coders love to add shortcuts to their code. They love shrinking the amount of stuff they type, so they use functions. Now, we have to define a function before we use it. Yeah, in order to use a function, we have to define it first. And so each function has an input, an output, and and it does something with either of those. Now, that's actually not exactly true. Some functions can have no inputs, and some functions can have no outputs. So let's try out this function right. I tapped out right here. I'm just gonna type it again. So you could copy, pause the video and copy that code, but I'm gonna type out a similar version, just with a shorter name. So add to. All right. So when I say function, it's just like that. It's just like creating a variable. Just like let variable equal some value, right? It's very similar to the structure of creating a variable. When I create a variable, I say let first, right? And then let tells the compiler, hey, we're going to create a variable using this variable name. Then we give it some kind of value using the equal sign. Now functions, right? Instead of saying let, we say function, right? Then we say the name of our function, so we can call in it later. And then we give it some inputs, some inputs. So number 1, and then comma number 2. Now you can give it as many inputs as you want. Ideally, you want less than like 5, otherwise it's crazy. And then we'll show you. I'll show you how to include like a ton of inputs later, and it's a thing called arrays that'll probably be the next lesson or something like that. So, sorry about that. So, these are our two outputs, and they're these are our two inputs, and each input is separated by a comma. Now I name these inputs, right? And I'm going to use these names, these variable names later on in the function. So how do you actually give it like this function a value? How do you actually have it do something? You type in the curly brackets, and then you press enter, and you'll notice that playcode.io, something that it has over like Notepad, I guess, it finishes the curly bracket for you, so you don't have to type that in. So where's the opening bracket? The opening curly bracket. If you can't find it, it's next to the P on your keyboard. If you're on a Windows, I'm not sure what a Mac looks like, but that's what it looks like on Windows. Yeah, it's next to the P, and it's above the square brackets. So you have to hold Shift, right, to press it. So now we have a function called add2, and I'm actually gonna do what I should have done in the last lesson. I'm going to zoom into my code. Whoa, not that much. Okay, so hopefully it's easier to see now. I'm also gonna move the console up to the top. All right, and I'm gonna delete preview for now. Oh no, never mind. I'm not gonna delete preview for now. Oh no, how do I? Oh wait, okay. Yeah, I'm just gonna have those two. Alright, don't mess with this too much. Alright, okay, so now that everything's zoomed in, hopefully you can see everything better. Alright, so what do I actually do with this function? And how do I give it an output, right? So I'm gonna write some comments to show you what I mean. So usually a function has an input, right? And then you throw it into the function, and then the function throws back out an output. That's like just like math, right? When you write like f of x equals like 2x, the input is x, right? The function is multiplied by 2, and then it throws you the output f of x, right? The output f of x. So in the same way, we have the function, we have two inputs, right? So this is kind of like I guess f of x, y, if you've done like, I don't know, multivariable equations. Don't worry about that. 2x plus or just like x plus y. This is a function with two inputs, right? And the inputs, I could just write x and y, but I want to be a little bit more descriptive here, so I'm gonna use number 1 and number 2. Alright, enough of me blabbering. Now let's actually write the function. Let sum, I'm gonna create a new variable, and it'll be the sum of the two inputs. Number 1 plus number 2. And then semicolon. And then how do I give it an actual output? Right now we're at this step, right? We only have an input and then a function. How do we give it an output? Well, we can give an output by writing return, some parentheses, I think, parentheses, and then sum. And then a semicolon. Alright, so now we have this function. How do we use this function? Well, we can either create a new variable, let new var equal, and then we type, in order to use this function, we type the function name, add to, then parentheses, and then the two numbers we actually want to put inside number 1 and then number 2. So I'm going to add just 2 and 4. Okay? And then semicolon. And let's actually log this to the console. New var. Okay. Now this is a small twist on now this is a small twist on the code I have here, and they're essentially the same thing. Okay. So what happens? Well, I created a new variable, right? And the value I gave it, how I get that that value is like this. When I call add to, the compiler grabs these two inputs, 2 and 4, and then shoves them inside of number 1 and number 2. So number 1 is now 2, and number 2 is now 4. Remember, by saying add to, my compiler looks for the function named add to, finds it, then it takes 2, shoves it in the first input, and then 4, and then shoves it in the second input. Now the function has number 1 and number 2. Then the function runs, right? It goes here. The code at this point hops into this code, line 3, 4, 5, and 6, right? Then it goes through line 4. It creates a new variable called sum by adding number 1 and number 2. And then it returns that. So after returning it, we hop back to line 8, and this becomes 6, right? I'm gonna undo that. So this becomes 6, and then 6 is stored inside of new var. Now when we log to that to the console, you see exactly 6. Sweet, our function is working. Now I guess the quick, or like the very logical ones that are watching this will notice, hey, that's the same as just writing 6, or that's the same as just writing 2 plus 4. Why would we have to create this whole function to just add 2 numbers? Well, hopefully you can see how useful this can become later. Well, if eventually we do way more than just add 2 numbers, let's say we then multiply them by something, and then we divide them by something, and then we apply a power to them, and then we sort some number. I don't know. If we do some crazy set of numbers or set of steps, then we can shove all of those steps into one line, and that shortens your code significantly. And let's say you want to repeat this process on like 3 different numbers. It's a lot faster if you have you can just call a function instead of typing out all of this code again. Okay, hopefully that makes some sense. All right. Now, this is where the people watching the live stream get some, get some extra benefits. Do any of you have any questions up to this point? And if you do, I'm not going to sit here and wait, because there is some delay between me asking this and you guys hearing it. So if you have questions, again, feel free to type them in the chat. Feel free to write them in the Google Classroom. I actually have that open as well. Feel free to email me, I guess, during the stream. I probably might not see that just because my internet speed is pretty slow. But other than that, yeah, just if you have questions, ask them at any time, and then we'll go over them. All right, what's next? So yes, this is another example of what functions might look like, and essentially, it's this. All right. Now I gave you an example where our function had an input, or 2 inputs actually, and an output. But some functions might not have either. And let me give you some examples of both. So I'm going to create a function, log to console, and I'm going to give an input string value. And then simply, I'm just going to log whatever it is, right? So, oh, I spelled string wrong. And I'm just gonna log it to the console, right? Now I'm gonna use this this function. I should be a lot cleaner about my code. I'm gonna go all the way down here. You can go ahead and create a new project. You can do what I'm doing. Excuse me. I'm just doing this so that I have a clean palette. Excuse me. And all the code we're writing isn't exactly very useful yet, so this is just like writing down notes. Okay, so you'll notice, hey, if you look at this, it's a function that only has an input, right? But no output. So, console dot, or sorry, you don't even type in console.log. I'm gonna call the function by writing log to console. That's the name of the function, and then I'm gonna give it like a Bob, right? And look, so when I call the function, right, it takes Bob, and then it stores it inside a string value, and then the function runs and it logs string value to the console. And you notice we don't have a return statement, so we don't actually return anything back, so we actually get nothing. And how do you actually check this? Well, let's try and log this. If it gave us back a value, it would simply log the value we wanted. And you'll notice undefined, because the function returned nothing. Now let's look at the opposite example. What if we have a function that doesn't take any inputs? No inputs. And then we want to return, say, 5. Always return 5. And then let's log this to the console. No inputs. And don't forget the parentheses. These parentheses indicate to the compiler, hey, no inputs is a function. And when I use these parentheses, I'm giving it these inputs. And you'll notice there's nothing inside the parentheses. So it's telling the compiler, hey, run the function no inputs using no inputs. No inputs. Yeah. So one thing before I move on. This thing right here, right? I've been calling it input, but a lot of coders have a different name for it. So some people call these parameters. Some people call these arguments, and they have a bunch of different names for this thing that goes inside of functions. And so it's your goal to just get used to all the different names, and if you can't, go ahead and Google it, and you'll find your answer. So again, parameters, arguments, inputs, these are all common names for whatever goes inside of here. And so you'll notice for no inputs, hold on. This goes up here. I need to really be neater about my code. You can tell I'm not a very clean coder. Okay, so this is a null to function to output. Yeah, so we don't give it anything, and the function just gives us an output. Now, you can see here that I skipped a couple. I skipped a step. Rather than saying let's new variable equal no inputs, and then logging new variable, I went ahead and just logged the output of this function, and that's one way to speed up your code. And I'll show you. Let's look at this old example here and see if we could do that to this example here. Let's try and speed up this example. Alright, so instead of writing let sum equals number 1 plus number 2, let's just go ahead and return number 1 plus number 2. And then instead of creating this new variable here, I'm going to delete that and just write add 2, 2, and 4. And look, I shortened the code by about 2 lines, which doesn't seem that significant, but it adds up if you make these kind of corrections or these corrections a lot. So yeah, that's how you be a little bit cleaner with your code. Alright, let's keep moving on. I have a functions part 3 slide, so more on functions. Yes, you can even make variables equal other functions. So I talked about, I'm going to create more empty lines. So I talked about how saying let variable or this var equals like some value, right? I talked about how the structure of this is very similar to a function, to like the creation of a function. Some function. Yeah, I'm gonna call this some var and then some var and then some function. Our function is just gonna return 0, right? Actually return some value. You'll notice that these are very similar, some function and some var, the creation of these variables. Or yeah, they're essentially variables. JavaScript treats functions just like variables. And I told you about how you can create variables in several different ways. You can use var or const. Well, think of function as just being another way to create a variable, but a special kind of variable. And that variable can be called upon. And when I say called upon, I just mean typing parentheses next to it. So again, when you type parentheses next to a function, it's called calling on that function. So again, functions are just like variables that you can call on. And so why is this so important? Well, check this out. I can create a new function, and set that equal to some function. Now, you would think, oh, would I include the parentheses here? And I wouldn't. I'm not calling on the function yet. I'm simply creating another function that equals this function. It will do the exact same thing as this function. And so now I can call on new function, and it'll give me some value. And I'll show you by logging that to the console. Whoa, that's crazy. Some value, right? Alright, so what happens is the compiler looks at new function, it finds that it has the same value as some function, and then it'll go to the sum function code. And the sum function code has no inputs, which is nice, because we gave it no inputs, or arguments or parameters, and then it returned some value. So the compiler took some value, jumped all the way back to line 45, and then logged it to the console. So again, we can make functions equal to each other. And an example of one that would require an input, you could say A and B. And then instead of returning just some value, we're going to return A plus B. And so when we call on new function, or you can see in the console, it adds undefined and undefined. If we give it two numbers like 2 and 3, it'll print, some value 23, right? It'll take these two inputs, it'll look at new function, see that it's the same as some function, and then go to some function, throw 2 and 3 in here, stick them onto the some value, and then we logged that to the console. So again, I've said it enough times, but functions are just like variables. All right. So here's another way to create a function, and it exemplifies, or it makes it more clear how you can make a function a variable in JavaScript. Let's look at arrow notation real quick. So I'm gonna keep going down. I know this is really bad because now we have like a 100-line code, even though it has only like 10 real lines of code. So it's fine. All right, we're gonna create a new function, and this time instead of writing function, we're gonna use let. And we're going to create a variable and then give it the value of a function. So let arrow function equal, and then here's what arrow notation looks like. And I'm going to write it out, and then I'm going to explain it. So it's a set of parentheses. You can tell that you're going to put your inputs in here, x and y. Excuse me. And then you're going to type the minus sign, right? The minus sign. Wait, no, not the minus sign. You're going to type the equal sign. It's under the plus sign and next to your backspace if you're on Windows. And then you're going to write a greater than sign, right? Just like a greater than, right? And then, now there are many ways you can do this. And I'm just going to write return x, y. Wait, hold on. Okay, you don't write return. I'm sorry. Oh wait, hold on. Wait, return x plus y. Yeah, I don't think you write return. Okay, yeah. I'm bad at JavaScript. All right, I'm gonna redo that. You know what? Yeah, it's fine. Okay, I'm gonna restart that entire section. So let's go ahead and create an arrow function. We're gonna create it just like we're creating a variable. Let's arrow function or arrow function equal, right? Just like we're creating a variable. I'm repeating myself at this point. Equal, and then we're gonna start with parentheses, and you could tell you're gonna put your inputs or parameters or arguments in here. I'm gonna use parameters x and y, and then we're gonna type the equal sign, which is under the plus sign, next to the backspace, right? Equals, and then the greater than sign, which is above the period if you're on a Windows computer, and then whatever we want to return. So I'm going to return x plus y. So now we have our arrow function, and we can actually log, our arrow function to the console. Arrow function of 2 and 3. And you'll notice it gives us 5. So this is what arrow notation looks like. Rather than we're going to compare it to function notation. Rather than the funny thing about arrow notation, right? Yeah, I need a right. Now the funny thing about arrow notation is that the function doesn't have a name. If you get rid of this part, you still have a variable here, and the value is this thing, this arrow notation function. And again, I don't even know if I finished my sentence, but this arrow notated function does not have a name. It doesn't have the name sum function. And so we can create another variable called arrow function and give it the value of this function, but the function itself doesn't have a name. And so that might be confusing. Why would you ever use arrow notation? Wouldn't you want your function to have a name? Well, I'll get into some reasons later, but for A, it helps with shorthand, and B, sometimes you just don't need to write, sometimes you just don't need a name for your function. If it's like a one-time thing, then you don't really need a name. And that's a yeah, I'll get into that later. It's essentially for callbacks, and I'll probably never get into callbacks in this series of lessons. I'll get into my advanced JavaScript series of lessons, but ignore that for now. Okay, basically, your arrow function has no name, so you're gonna have to create another variable to give this arrow notated function a name, and you don't have a return statement either. Whatever this is called an expression, right? Whatever this expression evaluates to, as in whatever ends up on the right side of this sort of arrow will be returned. So, oh, whoops. So if I just write like 5 here, it'll always return 5. Oh no. Oh, okay, we're good. All right, we're good. And then again, your inputs are inside of the parentheses. This makes sense. And so you can read this as take these inputs and then do this and then this is the function, and then come out with this output. That's how you can read sort of arrow notation. All right, enough with arrow notations. Keep moving on. All right, what's next? Okay, so this is another I meant to talk about comments here, but I already talked about it in previous lessons. But it's good to remind yourself, hey, I've been using comments this whole time, but this is what a comment does. It essentially makes it so that you don't include some random letters or some other stuff into your code. So yes, use comments. It makes your code more readable, and it won't affect your code, so you might as well just type a bunch of them in. Alright. Oh, do I want to go into this? I think I just want to go into scope. I think I'm going to skip this. Alright, this is another benefit of watching the live streams instead of just the lessons. You get to sit and watch me just kind of suffer for a little bit and be confused. Do I want to go into this? Sure. Okay. We're gonna go into this. Now let's look at an example of using a function that might be applied to your everyday life. All right. Yeah. We're gonna talk about libraries really quickly. So what is a library? Now, in the past. Yes, you want to go into it. Thank you, Power J. All right. So what is a library? It's now everyone's telling me to go into it. Yes, go into it. Alright, okay. Where was I? So what is a library? A library is essentially a variable, just like you know, the variables we've been working with. But when you work with this library, it has a bunch of, or actually no, I want to explain it a different way. So what is a library? A library is essentially a set of functions and sometimes variables that you can use inside of your code in order to add more functionality. So an example would be, hey, we've been working with console.log this whole time. Now, what does console.log mean? Now, we've been typing this dot and just log in console this whole time, but now that you know what a function is, this might make more sense, except for the period part. Okay, so what is console.log? What does it mean? Well, it means we're taking the variable called console, and we're taking we're taking the library called console, and we're taking the function log inside of it. So inside of this library called console, there is a function called log, and I'll show you guys how to create, I guess, your own library, or how to how to give a library a function. I'll get into that later, but all you need to know is that inside of this library called console, there's a function called log, and the log takes the input of, you know, whatever you want to give in here, some string, and then it logs it to the screen. So this is an example of giving your code more functionality. We wouldn't have been able to do this without the console library. So what other libraries are there? Well, there's a math library for things like doing square roots and powers and all that kind of stuff. So square root of, you know, 4, and the square root of 4 is 2. So if you guys, hopefully you guys have done some, like, a little bit of math. If you guys have done geometry, or I think they teach us in algebra 2, or algebra as well, not algebra 2, but what is the distance formula? And let's actually make a function calculator. Let's actually make a distance calculator. Distance formula. I'm gonna call it distance formula, or actually just find distance. So you'll take 2 points, right? So we'll take x1 x1 y1, and then x2 y2. So these are 2 points, right? 2 points in space. All right, and if you know, I'm not gonna draw out a whole graph here, but they're essentially 2 points in space, two coordinates, right? X and y, x1 y1, and then x2 y2. Now, a lot of you have probably dealt with square roots, but a lot of you might not have dealt with the distance formula. So what is the distance formula? Well, if you've dealt with the graph before, what is a graph? Well, again, if you, I guess, here, I'm going to do a multi-line comment. I don't know if it's, I'm explaining math at this point. So, let's say you have a, oh my, no, this is silly. All right, never mind. Okay. So let's say you have a graph, right? So let's say you have a graph, and a graph has the x-axis and the y-axis, right? Now it can take 2 values. The coordinate on the graph, x1, y1, will be a point on the graph, right? Like a dot on the graph with the x-axis and the y-axis. So it's a dot on a map, essentially. It's a dot on a map. And then you have another dot on the map. And x is how far to the right or left it is, and then y is how far up or down it is. And so how do we find the distance between two points? Well, I'll show you right here. Yeah, I'm just going to show you right here. So return, it's the square root, right, of the differences in the coordinates squared. Now, if that doesn't make sense, that's totally fine. Let me make sure I'm getting this right. Yeah, okay. Alright, so it's the differences in the coordinates squared. So let's take the difference in x. Here, before I write the whole function out, I'm going to map all this out. So I need, you know, the square root, sorry, it's the square root of the sum of the differences of the coordinates squared. Now I'm gonna break this sentence up, right? I'm gonna break this sentence up, and this is, you're gonna have to do this a lot when you're building your own functions. You're gonna have to get used to, you know, planning things out before you actually just start writing them out. So now this is complicated, but the first thing you have to find, right, is the differences of the coordinates, right? So the differences of the coordinates are x1 minus x2, and then y1 minus y2. Okay, we have the differences. How do you square them? You do this caret thing, which is above the 6 on your keyboard, and then 2, right? It's squared, and then we're going to square this. Now, if you don't know what squaring is or square rooting is, squaring is just having a number multiply by itself. So it's x1 minus x2, all of that, like let's say, yeah, all of that, and then this times itself, right? And then, you know, this squared is this times itself. Okay, so we have the differences squared. Now we have to find the sum of them. So we simply add these two numbers. Sweet, we just added the two numbers. Now we square root that sum. Alright, now we just do math.square root. Oh, I didn't explain this. Hold on. So what is math.square root? Yeah, there's a library built into JavaScript called math, and then we're taking the square root function inside of it. Again, by saying dot, it's saying, hey, look into this library and find the function called square root, and then we're going to use that. So now that we have that, we planned it all out. Let's pop that in the return. Now it's going to return this, and that's our output. Now we can find the distances between different points. Let's log them to the console. Let's find distance between coordinates 2, 4 and 3, 9. And the distance, whoa, where did I mess up? Hold on. The distance can't be 0. 3, 6? Why am I getting wacko values? This doesn't make any sense. Oh no. Hold on. This is really embarrassing. Hold on, let me try 4, 2, 6, 3. Another benefit of watching the streams is you get to see me fumble around and be totally confused. Okay, these are y2 and x2, right? Okay, yeah, x1, y1, x2, y2. x1 minus x2, y1 minus y2. Wait, hold on. Maybe I think the problem is, or wait, no. Okay. All right. Now, you can obviously see that I'm struggling here. Now, rather than, just fix the problem and then cut this all out, I'm going to show you how you would debug this. All right. So how would you debug this? I have a bug, obviously. I'm getting NaN when I should be getting like the distance between these points. How do we debug this? Well, let's look at all the variables. Let's make sure we're getting all our variables correct. X1, wait, Y1, X2, Y2. Oh yeah, this is another cool thing you can do with console. If you put commas, it'll just space them out like this. So okay, that's working. All right, we have that at least. Now let's log out X1 minus X2, and then Y1 minus Y2. Is that working? Okay, we have those. All right, now let's log these squared. Squared. Wait, no. This shouldn't be. Wait, hold on. I'm gonna do another line. Another line. Yeah, another line of code. Let's keep doing this. X1 minus X2 squared, and then Y1 minus Y2 squared. Wait, -1 times -1 isn't -3. Hold on. Why isn't it squaring things right? Oh, okay. Oh my, are you serious? Wait, what? Hold on. Oh, okay. All right. Hello everyone. Oh, Power J says you need a space between the plus and the carets. Like this. That's not the problem. Otherwise, it's adding exponents. here, let's try. I think I know what Jay is talking about. Let's add the parentheses here, right? If you add parentheses here, you take you know, the squared items, right, and then you add them just in case it might be like, let's what it might be doing is, you know, instead of doing what we want it to do. Okay. So I got a response from the comments. Their suggestion was to add parentheses around things such that, or like add spaces around things such that maybe it's taking the powers of these instead. It's taking the power of 2 to the plus this instead of just this squared and then this squared. So it works for you, really? That's crazy. Okay, well, we're gonna. I realize you know, okay. This is going amazing. All right, so I just realized. All right, I'm back. All right, I'm back, everyone. So I found the error, and it's that in JavaScript you don't actually use the caret to do powers. You do the multiplication sign twice. So so the multiplication sign twice should fix everything. Yeah. Yeah, if it's working for you with the double caret, like the double caret, or like just a caret, then I don't know, that good job. That's crazy. I don't know how you're doing it, but with two exponents, it should work for sure. So this is the distance, right? And then you could add some, you know, the distance between the points is, oh man, that doesn't work. The points is and then you can put that down here. Get the equal sign down there. Okay, yeah. You can kind of just mess around with the lines. All right, so yeah, this is this. All right, we found the distance between the points, and then we got it. Okay, so we're done with that example. Let's keep moving on. We're gonna get into scope now. So what is scope? Now this is probably the hardest thing for a new coder to get to understand. Up to this point, you know, variables, Boolean operators, functions, it all kind of makes sense. But now we're getting into real computer science, right? We're getting into real understanding of our code. So now this is a huge block of text, but all I'm saying is there's different scopes in coding, kind of like how now if you let's hope you have some idea of what a scope is. I'm not talking about like telescopes or like you know, like microscopes. I'm talking about the scope of something. So an example would be if let's say you're looking from a satellite, right? And you're in the satellite. Okay, actually, okay. Let's say there's a cake in a house. Okay, this is my example. There's a cake in a house. Now, if you're sitting in the house, you can see the cake, right? But let's say you were sitting in a satellite that was, you know, out in outer space orbiting around the Earth. Would you be able to see the cake from that point? And the answer is probably not, right? Now, let's take another example. What if you know, there's a sun, right? We all have a sun, right? And if you're sitting at the house, or like if you step outside the house maybe, or there's a window in the house, you can see the sun, right, from inside the house. But you can't, but the satellite can see it as well. So the scope, right? There's a big scope, right? Orbiting around the Earth. There's space, right? The telescope, the satellite can see, you know, that global scope. It can see the sun. It can see the Earth. But it can't see inside of the house, right? Then we have the local scope, right? We call this the local scope. You're inside the house. You can see outside, right? You can see the global scope. You can see the satellite. You can see the sun. And you can see the cake, something that the satellite can't see. So we have global scope and local scope. And let me put it into let me put it into perspective. All right, let's keep coding. I'm gonna keep moving down. Or actually, you know what? We'll just keep this. Okay, we keep moving down. All right. I'm gonna create a variable. Let's, you know, what are we gonna call this? Let food equal cake. All right, we have our cake. Wait, no, actually, sorry. No, this is the global. Okay. Now, before I get into an example, this coding space that you're working with, the outside, right? When if you're just coding right here, let variable var equal some value. This is in the global scope. This variable here is in the global scope. When you're working on this outer space, you're working on the space level scope. You're out in the satellite, right? Now, how do you enter a local scope? How do you enter a house? Whenever you create a function, right? Function, this or random function. This is a local scope. Local scope. This is alright. When you're out here, you're on global scope. So I'm going to create a global variable. It's called a global variable because it's sitting on the global scope. Let sun equal sun. This is a very well named variable. Now we're in the local scope. Let cake equal cake. All right. Oh, I'm going to create another example of a local scope. Essentially, if true, essentially, whenever you have these curly brackets, you're entering a new scope. And if you put curly brackets inside of curly brackets, then you're even in an even smaller scope, right? You're what inside of the cake or whatever. I don't know what other example there is. Yeah, you're essentially going deeper into this rabbit hole, right? This is the inception. This is a local scope. You're even deeper in the rabbit hole. Okay, but I'm just gonna work with the local scope and the global scope for now on. Okay, so let sun equal sun. We're gonna go inside of our function, right? I'm gonna ignore this as well. I'll delete that as well. We're gonna log here the sun or the sun variable, right? We're talking about variables here. Log sun. And you'll notice, all right, it will log. Oh wait, I have to call in the function first. Or actually, yeah, instead of doing function, I'm gonna do if true. It just makes things simpler. If true. All right, so we're inside of a local scope. All right, sweet. It created a sun, and we have the sun. It logged this is inside, right, and this is outside. So it runs through the local scope. It creates cake inside of this house, right, this local scope, and then it logs sun, right. So we see sun over here, and then we we're on the outside scope again. We're gonna log sun again. So what if we tried to log cake, right? Well, let's log cake inside the local scope. We're inside of the house. We can see the cake. You'll see cake. But what if we're on the global scope? Let's log cake. You'll notice cake is not defined. And I'm surprised it didn't even give us undefined because we didn't even say let cake. We simply didn't have a cake at all. We didn't have any cake, oh no. So you can see here, if we're in the local scope, we can access everything inside of this local scope. But if we're on and we can even access what's on the global scope, we can access the sun. But if we're in this global scope, we can't access whatever's inside of here. Now this is where var comes into play. Let's create a var cake instead. Var cake. Now, actually you might have got sneak peeked already. Alright, yeah, you can make a prediction. What if you made this var instead? What do you I've been ignoring var this whole time, but what if you used var instead? Var cake equals cake. Whoa! What it actually did was it created a global variable. So var creates global variables. Var cake is now inside the global scope. It's like you're in the house and you create like this ginormous cake that shoots outside of the house. It breaks open the house and even the satellite can see it now. So that's what var does. And you can even try. Let's try const. And you'll notice, okay, const only does local, and let's try to create a function. Wait, that's a bad idea. Hold on. Yeah, you guys can try function on your own. That'll be your little test. Okay. So now you guys know about scope. Alright, this is an example of scopes in practice. And it's basically everything that I just talked about. It's using let and it's using var and it actually yeah. Yeah. One more. The only thing I'm gonna take away from this. Okay, you could pause it here, read through all these comments, but I'm gonna take one more takeaway. I'm gonna get one more takeaway out of that, and it's this: if that we said if true here, right? And if we said var here, right? If we say var here, it creates the global variable kick. But what if we have inside of a function, new or random function? What if we created a variable inside of here, var, ant. I don't know why I'm thinking of ants right now. Okay, ant. What if we tried to log ant here? You can make some predictions. Well, it's inside of a local scope, right? But it says var. So if we log ant in the global scope, console.log ant, you would think, hey, you would get ant. But you'll notice, hey, we didn't get ant. And why? It's because we didn't call on random function yet. Because this code didn't even run, it didn't even create this global variable ant. So let's run this function right here. And you'll notice this function has no inputs or outputs. It just does some stuff. Whoa, this is even more crazy. You'll notice it didn't even, even though we ran the function, it didn't even, create this global variable ant in the right way. So you'll see that, yeah, this is really weird. This is really weird. Even if you run a function, var won't make it global. So it only works inside of ifs or else's. All right, so let's get rid of that. And I think one more takeaway. This lesson has to end in like 5 minutes. Actually, excuse me, I'll cover it next lesson. So let's review. What are functions? Excuse me. Well, they add more functionality to your code, and they break down huge codes of blocks into simple function calls. Functions can take inputs and produce outputs, but they don't always need both or even either. We can make variables become functions, and we can also make them become copies of each other. And arrow notation is a shorthand for writing functions that don't have function names. We can also get pre-made functions from other libraries, like the math library or the console library, and then call on them using the library name, a period, and then the function name. This helps us add even more functionality to our code without us having to write out huge, function blocks. And also, make sure you comment your code. This will, help you remind you what your code does, but it'll also make your code more readable for other people. And also, we tend to work in this global scope, but whenever you add curly brackets, you create a local scope. And the only way to get from the local scope to outside of the global to the outside scope, you need to use var instead. So that's basically it. I don't have any practice questions for you guys, but totally mess around. See if you could break this whole local scope or global scope thing, and let's see if you could come up with some solutions to the problems that might arise with global and local scope. Yeah, essentially, try and break your code. Try and see if you can find some weird exceptions, and then debug your code using logs or console logs. So that's basically it. Thank you guys for coming. Again, join the Google Classroom if you haven't. That's basically the lesson. Thank you guys, and keep on coding.